astronomers are closely monitoring an immense and potentially transformative astronomical event that may significantly reshape our understanding of the cosmos. Betelgeuse, a massive red supergiant star located on the outskirts of our galaxy, has begun to emit signals suggesting it may be approaching a significant and final transformation in its stellar life. Using the advanced capabilities of the James Webb Space Telescope, scientists have observed unusual characteristics in Betelgeuse's behavior, raising serious questions about what lies ahead. Astrophysicist Brian has offered a measured warning, prompting the scientific community to consider whether we might be witnessing a rare and powerful event that could permanently alter the appearance of our night sky. The possibility looms that Betelgeuse could soon end its life in a supernova, releasing an overwhelming burst of energy. To understand the unfolding circumstances around this star, one that has intrigued both professional astronomers and casual observers for generations, requires a closer look at its current state and the forces at work. Betelgeuse is located in the constellation Orion and is a red supergiant of extraordinary size and age. Known for its distinctive reddish color and variable brightness, Betelgeuse has become an object of fascination in the field of stellar astronomy. Recent findings, however, have heightened interest in the star due to noticeable changes in its behavior. With a diameter approximately 764 times greater than that of the Sun, Betelgeuse is a true giant. If it were to take the place of our Sun, its surface would extend far beyond Mars's orbit, encompassing Mercury, Venus, Earth, and Mars itself. This immense size hints at the powerful processes taking place within the star's core, but its scale is just one aspect of its significance. Currently, Betelgeuse is in the final stage of its evolution, known as the red supergiant phase. After billions of years spent converting hydrogen to helium in its core, the star has expanded and cooled, though it is estimated to be between 8 and 8.5 million years old. A brief existence. By stellar standards, Betelgeuse is considered ancient. Stars of this mass have much shorter lifespans than smaller ones like the Sun, and Betelgeuse is nearing the conclusion of its evolution, having transitioned from a hot blue star to the cooler red supergiant visible today. It is now undergoing internal shifts as it burns through its nuclear fuel, shedding mass and altering structurally from within. The star's red hue is one of its most recognizable traits. Unlike the Sun, which shines a yellowish light due to a higher surface temperature, Betelgeuse is cooler, radiating at approximately 3,500 Kelvin, significantly less than the Sun's 5,500 Kelvin. This cooler temperature gives Betelgeuse its red color, a clue astronomers use to infer details about its internal state and stage of evolution. Interestingly, historical records from various civilizations suggest that Betelgeuse's appearance has changed over time. Ancient Roman and Chinese sources indicate that about a millennia ago it may have looked yellow. By the 9th century, Arabic astronomers described it as red, suggesting that the star's transformation has been ongoing for centuries. These accounts provide valuable context for understanding Betelgeuse's long-term development. Betelgeuse is also classified as a semi-regular variable star, which means its brightness changes in predictable cycles. These cycles occur roughly every 400 days, with longer-term variations over periods of about 5 years. However, the star does not always follow these patterns consistently. Betelgeuse sometimes exhibits unexpected deviations from its regular brightness cycle behaviors not yet fully explained by existing stellar models. In late 2019, the star experienced an unusual and dramatic dimming event that drew global attention. Known as the Great Dimming, this significant reduction in brightness was so prominent that even amateur astronomers could observe it without sophisticated equipment. At its lowest point in February 2020, Betelgeuse's brightness was decreasing at a rate of 0.01 magnitudes per day. This event triggered considerable interest and concern among astronomers, as it raised questions about the star's future. One important aspect to consider when studying distant stars like Betelgeuse is the concept of light travel time. Betelgeuse is located roughly 725 light-years from Earth, meaning that the light we see from it today began its journey to us around 725 years ago. Therefore, any change we observe now actually occurred in the distant past. This time lag complicates efforts to monitor and interpret Betelgeuse's behavior, as astronomers are essentially analyzing the star's history rather than its present state. If Betelgeuse were to undergo a major transformation, such as a supernova, we would only become aware of it long after the event actually occurred. Despite this limitation, astronomers continue to examine Betelgeuse's fluctuations with great interest. The Great Dimming Event prompted a focused investigation into possible causes. A research team led by Andrea Dupree at the Center for Astrophysics at Harvard and Smithsonian used the Hubble Space Telescope to observe the star's outer atmosphere during the event. They discovered that Betelgeuse was shedding material from its outer layers at extraordinary speeds, about 200,000 times more than typical solar mass ejections from the Sun. This material formed a dust cloud that partially blocked the star's light, offering one plausible explanation for the dimming. The formation of this dust cloud prompted speculation that Betelgeuse might be entering a terminal phase of its evolution, potentially leading up to a supernova. There are several hypotheses regarding what caused the dimming. One theory is that Betelgeuse is progressing through a stage leading to a supernova, while another suggests that dust from ejected stellar material obscuring our view. A third possibility involves changes in the star's photosphere affecting its observed brightness. Further studies suggest that the dimming may have been caused by the ejection of superheated plasma from a large convection cell on the star's surface. As this material traveled outward, it cooled and solidified into dust particles, eventually forming a cloud large enough to obscure significant portions of the star's visible light. The scale of this ejection is staggering, estimated to be about 400 billion times the mass of the typical solar coronal mass ejection. Such a substantial loss of mass raises important questions about Betelgeuse's remaining lifespan. This brings us to a critical question: when will Betelgeuse explode as a supernova? Estimates vary widely. Some astronomers suggest that the star could go supernova within a few decades, while others propose that it may still have up to 100,000 years left, regardless of when the event occurs. One thing is certain: Betelgeuse is in the final stages of its stellar life, and we are fortunate to observe its late evolution. If it does explode within our lifetimes, the event would be classified as a core collapse supernova. This occurs when a massive star can no longer support itself against gravitational collapse, resulting in an explosion that emits more energy than our Sun will produce over its entire existence. Though Betelgeuse is relatively close in astronomical terms, Earth would not face any immediate threat from such an explosion. However, the opportunity to witness a supernova up close would offer unmatched scientific value. Studying such an event would provide critical insights into the life cycles of stars, the formation of heavy elements, and the broader dynamics of the universe. As we continue to observe this ever-changing celestial object, we may soon witness one of the most extraordinary natural events the sky has to offer, reminding us once again of the vibrant and ever-evolving nature of the cosmos.